Most of the LED lamps used in our homes, here in Europe, come from China. The quality of these products, however, depends on the importer, who has them built according to his own specifications. So if we buy from a serious importer, who displays his brand, we will be sure that we have purchased a durable product. But, if we buy products of little known brand, or worse without brand, we should not expect a long life. In year 2013 I decided to replace all fluorescent lamps in the house with LED lamps. Back then, these lamps, especially if branded, cost much more than today. I had bought a batch of lamps from a Chinese importer at a good price, believing I had made a deal. But things turned out differently. After 15 days the first lamp burned, and within a few months, everything else. I went back to using fluorescent lamps, and only after a few years I replaced them with LED lamps, with the IT brand, of course always built in China. But these did not create problems, their duration was around 4 to 5 years. Now I found 2 of those old burnt lamps visible on the screen, and in the following video I intend to find out why they broke down so quickly. Disassembly of the lamp is quite simple. The main parts of the lamp are held together by an acrylic adhesive, and with a small knife and a screwdriver, it is relatively easy to detach the transparent globe. I then proceed to detach the individual rigid strips of the SMD5050. The diodes are connected to each other all in series, and each strip has 5 diodes. Now I cut the connecting wires between the strips, because these will be checked individually. Now I proceed to the stripping of the connecting wires, among the 9 LED diode holder elements, so I can test them individually. A CMOS lamp is composed of 9 strips, each containing 5 SMD50 LEDs. The general characteristics of this component are visible on the screen. Each SMD50 contains 3 LED diodes, and each of these diodes must be powered with 20 mA. Since these 3 diodes are powered in parallel, the SMD50 needs 60 mA, which is its rated current, which corresponds to a supply voltage of about 3 volts. Remember that the LED diodes must always be powered by controlling the current, not the voltage, because a small increase in the supply voltage corresponds to a strong increase in the current that passes through it. And this, if not properly controlled, can lead to the destruction of the component. The electronic power supply circuit of the lamp is now shown with its wiring diagram underneath. As already mentioned, we have to feed 9 strips of 5 SMD50 each. In all, 45 LEDs that at 3 volts each, require 135 volts for the power supply in series. Referring to the diagram on the screen, we see that the two capacitors from 470 nanofarad marked with an asterisk should guarantee a voltage drop of 95 volts. Note that the electronic circuit works perfectly and has no fault. The fault we will find it later in the LED diodes. So what caused the LED burn? It was the tolerance of the two 470 nanofarad capacitors, which from checks I made goes around 20 to 25%. Too much for use in this circuit. With too high values of these capacitors, the supply voltage of the output of the circuit rose too much and led to the premature death of the LEDs. A big design mistake. Another mistake is to have connected all the diodes in series. Just a fault of a single diode and the lamp goes out. And now we'll check on the LED strips. I prepared the power supply for an output of 15 volts and proceed to power the strips. The first turns on, current absorbed 60 milliamperes. The second strip also turns on, with a current of 60 milliamperes. The third instead does not turn on. We found the fault. Looking closely you can see the last LED on the left slightly blackened. It burned out. The fourth works. The fifth is also okay. And all the other four strips also work, but the failure of a single chip has made the lamp unusable. And now the 15-watt lamp has exactly the same type of power supply, only here, we have a dual power supply. The aluminum plate that supports the LED and serves to cool them, is fixed to a robust heat sink with large fins. We have two groups of 42 LEDs connected in series, each powered by its own power supply, the same type as described before, and consequently the lamp could only have a short life. What you see now, is instead the power supply board of a 6-watt, high-key LED lamp. Its duration was 4 to 5 years, it is always of Chinese origin, but the quality here is there. Nothing to do with the previous lamps. For its duration it is essential the presence of the constant current regulator chip, indicated by the arrow. Thank you for your attention, to the next.